Shrewd Manager Christianity's Position. Radiocarbon tests tell us more about how the shroud image formed than when. Part 2. Imagine a Gothic cathedral built continuously from 1100 to 1400. No one would average these and date the construction to 1250. Yet this is what nature did when they averaged the 3 labs' radiocarbon dating results. The lab's failed chi-square tests signal that, like the cathedral, the shroud's corner cannot be treated as a single uniform age population. However, while the labs did not discover a uniform date, they did reveal a statistically significant pattern. Threads trend younger toward the cloth's center. What could cause this? Here we consider 3 intuitive natural explanations for this gradient: repair, contamination, and fire effects. Each one shows promise, but ultimately fails. They all lack causal adequacy. Number 1, was the corner a repair? This is reasonable and intuitive. The tests show new and old threads because the sample contains new and old threads. Microscopy, UV fluorescence, and microchemical tests show the corner differs from the main cloth. Cotton fibrils, dye, and a gum-like coating appear only in the radiocarbon region. History says repairs were made throughout the centuries. Common sense says such repairs were likely made to high-handling areas, like where the samples were cut. All of the major European courts had teams of skilled weavers employed to repair high-quality textiles. The 16th century weavers were magicians at concealing their handiwork. At that time, the shroud owners were one of the wealthiest, most devout families in Europe, ideal patrons for such a task. Joseph Marino has documented modern firms still capable of astonishingly subtle invisible reweaves. The evidence is so strong, we initially argued that the corner was likely a medieval repair, so doesn't tell the shroud's age. However, we now concede this mechanism is too weak to account for the direction and magnitude of the gradient. Putting numbers to the question clarifies why. The raw radiocarbon dates range from AD 1090 to 1389, a 300-year span. Even assuming a smaller 200-year offset, a cloth woven in 1200 needs about 1/4 modern fabric to yield a radiocarbon date of 1400. Such a heavy blend would be visually and chemically obvious, but that's not what we see. We reject the reweave for other reasons too. First, experts inspected the corner before it was cut and insist there's no reweave. Second, pre-1988 transmitted light photos show the weave pattern and water stain boundaries are continuous across the corner. No patchwork disruption. Third, importantly, a reweave would produce younger material near the edges, yet the data show the opposite. Number 2, did contamination alter the carbon-14 readings? This question has potential too. Handling over centuries, microbial films, and biogenic coatings can affect radiocarbon dates. Microchemical tests and FTIR spectroscopy confirm a carbohydrate film in the corner region, consistent with starch or sizing historically used to process linen. Such residues can shift dates, but this too fails for several reasons. First, the mass balance problem reappears. A cloth made in 1200 needs about 25% modern contamination to register a birthday of 1400. This would be plainly evident under microscopy and spectroscopy, yet that's not what the shroud shows. Second, all 3 labs used aggressive cleaning protocols and validated their methods with control fabrics. Third, ordinary contamination produces random scatter, or a uniform bias, not the smooth, directional gradient seen across the tested corner. Number 3, could the 1532 fire be responsible? This idea is appealing. Heat can chemically alter cellulose, helping it absorb carbon from the surrounding smoke or gases. It is scientifically, visually, and historically attested that the shroud endured intense heat smoke, and soot during the 1532 fire. And since the younger radiocarbon values occur nearer the center, exactly where heat and damage were greatest and carbon absorption most likely, this theory seems to anticipate the lab's findings. Where there's more heat, there's more carbon and a younger date. However, the math shows the idea doesn't work. To shift a linen woven in 1200 to a radiocarbon date of 1400, the fire must supply about 60% of the total carbon in the tested threads. But no fire can do that. Linen simply cannot absorb or retain anything close to that amount of new carbon without being chemically destroyed or physically transformed into a char-like material, which the shroud clearly is not. And even if heavy soot or smoke had settled on the cloth, the lab's cleaning strips nearly all of it away, leaving nowhere near the level of fire-derived carbon needed to shift the date by centuries. There are other problems. Fire contamination is naturally uneven, patchy, and imprecise, but the shroud's radiocarbon data show a smooth and steady gradient across just a few millimeters. Laboratory tests agree. Even when flooded with carbon monoxide, linen shows zero measurable carbon absorption. This despite measurement sensitivity fine enough to detect changes of less than a year. In some 4 peer-reviewed studies show the labs got their measurements right, but the medieval date that Nature reported cannot be justified statistically. The data reveal a real directional gradient, older at the edge, and none of the usual explanations, repair, contamination, or fire, can account for this pattern. Next, since commonplace mechanisms fail, we must consider more exotic explanations.